Hi, this is Tariq Rashid. Welcome back to our new class about decision tree. This is part two. Part one was a theoretical part, and part two is providing a simple example on how you can implement decision tree and how it can be simplified in a way that you can understand it better. So, decision tree is a machine learning technique, a supervised machine learning technique. The main purpose of this tree is to make sure to split data into subsets and you find pure and non-pure part of each feature, and you go further down to split until you will create your own tree and then you test it. That's more or less about the decision tree. So, how you can do that? Via using impurity or information gain, the measurement that you select, that you calculate the measurement at each level in the tree. So, and this measurement we call entropy or entropy. So we'll find the data set, we'll have a data set and we'll find entropy at root now, data set level and at feature level. Once we have a high entropy, it means that bad classification will which will make a split. Once we have low entropy, that means we have pure classification. This is the data set sample that was giving. We have 7 samples. We have 2 features, weather and humid. Feature has 3 values, sunny, overcast, and rain, whereas humidity, it has high and normal. And this is the play. Sorry, that's the play. It has no and yes class play. So having the weather, having the humidity, whether we play at that day or we don't play, that's the problem that we have. This is the entropy. The entropy is can be found in this way. So you have probability for each class, block base 2, probability of each class, and sum all these probabilities for each class. Sort of the data set, we have 4 yeses in the samples and we have 3 no's in the samples. Total of them 7 samples in our data sets. Now we try to find probability for data set in the class, which is play. So we have 4 over 7, the total sample for yes, and for no, we have 3 samples over 7, and we plug them in, and we will find the entropy. The entropy was 0.985 for the class, for the label in the data set. Now, the first step was found. We come to the second step, which we will try to find gain for each feature in the data set. We did for the label class, we'll do for each feature. Now, therefore, we will have for each feature, a feature, sum them up. We'll try to find entropy for each feature in the data set. So it means we have to find the entropy for 2 features we have. One of them weather. So and we try to find each value in the weather, sunny and overcast and rain. So 3 values we have for it. And this whole, the total entropy at the class level, at the data set level, minus the entropy at the feature level. That's feature level. And this is the class level, which is data set level. Now, for the feature, we have weather. Weather, it has 3 values. So we'll go with first one, sunny, and then overcast, and then rain, we'll find it. For the sunny, we have two no's and no yeses. The entropy is zero, and we will tell you how we found entropy. Two values we have. Yes, we don't have yes, so the entropy for yes is zero. I mean, there's nothing in it. For no, we have two samples, no, over the total samples, two. So the entropy is log 1, that's 0, and log 0 for the yes is 0. So we find entropy is sunny, no. For the overcast, same like sunny, we have two yeses, but we don't have no, which is a pure now, easily classified. Two yeses and no is nothing. So 2 over 2, 1, and plug them in, it is entropy 0. For the rain, now the situation is different. We have two yeses and one no. So two yeses and one no. So we have 2 over 3, two yeses, and one no, 1 over 3. So this is the information that we found it for the rain. Rain. Now, two yeses over one no, and it was found 0.918. Now, this found detail of the calculations. Now we add to, this is for sunny, and this is for overcast, and this is for rain. Sum them up, we found this one. This is for the whole weather, and this is the total information gain at the class level. So subtract this minus this, and we'll get 0.92. Likewise, we do it for humidity. Humidity, it has two values, high and normal. For the high, we have 4 samples, 2 of them no, 2 of them yes. So we will find the entropy, 2 of them yes, 2 of them no, over total samples 4. So the entropy is 1 for the high. That's fine for the normal. For the normal, we have 2 yeses, 1 no. Again, we have to do it. 2 yeses, 1 no. 2 yeses, 1 no. 0.98. Now calculate them. 4 high and 4 normal. You'll find 0.96 for humidity. Subtracted from the class data set, which we found it earlier, so 0.02. Now you can see the results. It's now a bit clear. So weather here is 0.952, the information gain, and here is 0.02. So we will take this one. That's more can split the data. So the root will be weather because it has more information gain. Now, then we will, our best split will be weather because it has more information gain, and we selected weather. We didn't select the humidity. So the starting point is weather. Now we try to create branches starting from weather and check each subset and decide whether to stop or split further. So we started with weather, that's high information gain it has. We come to the sun, we come to the overcast, we come to the rain. Sun, it is purely understood. It was 2 no's, so information gain is 0. So this easily decided. Class, no. So decision is no, because it's pure entropy. For the overcast, 2 yeses, and nothing is no, so 2 samples. This one easily can be decided as yes. Then it comes to rain. In the rain, we have 3 yeses, 1 no, so it cannot be decided. So we need to go to see, to expand or check the next feature, which is humidity. Here in the humidity, we will see one sample is high, yes. Okay, which gives you yes. The value high, which gives you yes. So the entropy is zero. It's pure. Can be understand. One sample yes, no is nothing. So here log one and log zero, then it's zero entropy. So easily decided. And then we come to the normal. That's a bit mixed class. So one of them is yes, one of them is no. So the entropy is mixed. The entropy is not zero. The entropy is high, okay, which is completely one, okay, completely one. Therefore, we need to stop at here. Entropy is one. Therefore, and we calculate, we sum it up with the high, which was zero, then that's 0.25. Here, if we try to find, we go further down to see whether if we have any feature or value. No, nothing after, because the whole data says we have two features. Weather, we started with weather. Sunny, we decided. Overcast, we decided. And rain, humidity. Humidity comes high, yes. But normal, we found it 0.25 here, 0.251, 0.251. So it cannot be decided. So I think there is a technique to decide about this one. Uh, we either we try to see if there is more uh, attributes to expand. In this case, we do not have attributes to expand. We do not have attributes to expand. So in the rain, I mean, this is done, this is done, this is done. In the rain, it was not pure. We try to expand. There's no attributes remain. So here we cannot do. So data still mixed. It is 0.251. We can't decide. So there's a technique that we can either go yes or not randomly or by majority, which is the in the class what it says. Global class majority. It says that we have four yeses, one no. Therefore, we can just say rain normal yes because majority of the class says yes. So if you encounter a feature, it has rain and normal, whether it's rain and normal, then we go for yes. That's more or less about the weather. So it should be here, weather. Okay, so like that. Okay, that's our tree. We managed to do it. We found basic rules. If weather is sunny, straight away is no play. If weather is overcast, straight away is yes. If weather is rain and humid, if weather is rain and humidity is high, then play yes. Rule number four, we can say this was the kind of we couldn't decide very well. We went for majority. Weather, rain, and humidity is normal. We said play yes. So let's try to conclude this work with a testing sample where we have first sample sunny, high, and imagine we don't know the prediction. We haven't done it yet. So let's say we don't have this one. So we have sunny and high. We have overcast and normal, and we have rain and normal. These are the testing data. Now we check the testing data. If we go by the tree, sample one, the tree that we created, it's weather, yes. Sunny, we come here. If it's sunny, then play. So that sample, it classified as play with no problem. Second sample, weather, forecast, value forecast, you come here, and then humidity normal. It doesn't really matter because when you come to overcast, by fact that it's yes. And the third sample, weather, rain, and humidity normal, you come here. Okay, and majority of the voting, when you have rain and humidity normal, weather rain and humidity normal, then you come for yes. So that's all about today's class. I hope it was useful. If you have any information, just go to my website and drop me an email. This was a practical part. The first part was tutorial, theoretical part. Thank you very much and stay tuned.